everyone. Today in class we're going to be discussing addition and subtraction algorithms, and if we have time today we're going to be doing decimals as well. So just before we get started, I wanted to go through and make sure we are able to identify what we're going to be doing today and what you're going to be getting out of all of this. So I want you to be able to identify what an algorithm is. You're going to be able to compute problems using the standard addition algorithm with whole numbers. You can use the standard subtraction algorithm with whole numbers. You're able to demonstrate the regrouping process and use bundles to solve problems. And you're really understanding to carry over the 1 to the left column when using the addition algorithm, as well as the subtraction. So just before we get started, I kind of just wanted to refresh our brains and go through the basics of subtraction and addition. So addition is seen when a plus b equals the total number of units. The number a and b in sums are called terms, add-ins, and sum-ins. So an example of this could be 6 plus 4 equals what? So over here, our 6 is our A, the 4 is the B, and then we're really trying to find the total number of units. So we're trying to find this. So this is a big question mark. So 6 plus 4, just for the problem, it is 10, and then 10 would be our total number of units. For subtraction, this is seen when a minus b equals the total number of units left. The number of a units is taken away from the number of b units, and a and b are called terms. So we can do 12 minus 2 equals, well, we don't know. So 12 is our a, and 2 is our b. So we can see this problem as Miss Gartland has 12 apples and eats 2 apples during the day. So how many apples does she have left? So 12 minus 2, if I had 12 and I ate 2, then you would have 10 left. This would be our total number. That's a little refresh just so we're able to understand that process. So you may be asking yourself, oh, what exactly is an algorithm? An algorithm is a method and / procedure for carrying out a calculation. For the standard addition algorithm, we have broken it up into 3 steps. Step 1 is place the numbers on top of each other. Step 2 is line up the place values. And step 3, add column by column. I really want you guys to understand that columns are up and down. I know you may want to go side to side, but it's very important that you do know you are doing the addition up and down. So when adding, if the number exceeds or goes past 10, then you're simply going to put a 1 on the column to the left. So this, you'd be plusing 10. So we're going to start off easy, and we're going to do 123. So we're going to step 1. We're placing our numbers on top of each other. 123 plus 74. And we're going up and down. So we're starting off in this column. 3 plus 4 is 7. Then we're going to go to our left again. 2 plus 7 is 9. And if you guys don't ever see a number, it's just going to be 0 under. So 1 plus 0 is 1. So you would get 197 as your total number. If this way is a little confusing for you, we use bundles. And bundles is an interpretation as combining objects together. Each bundle represents a power of 10, and any numbers can be represented as a collection of these bundles. So I find it easier to use shapes. So let's say a circle equals 1, a triangle equals 10, and a square equals 100. So we're going to change the color just so you're able to see. Oh, I guess I changed it on the whole board. Oh well. But, so when we're looking at it, we have 200. So we know 100 is a square. So we have 2 squares. And then we have 7 tens. We know a triangle is a 10. So we have 7 triangles. And then 4 ones. And we know a circle is a 1. So we have 4 circles. And on the other side, we have 100, so 1 square. We have 14 triangles. That's a lot of triangles. And then 34 ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. So you're probably like, oh my gosh, like how am I able to tell what I'm going to be doing? And so applying the knowledge on over here, we're able to see, okay, 10 circles equals 1 triangle. So 10 circles equals 1 triangle. And we can repeat this process. So 10, we have another triangle. 10, we have another triangle. Oh, we don't have left, so we're just going to leave the 4 circles. And then we're able to see that 10 triangles equals 1 square. So we can go, okay, 10 triangles equals 1 square. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're able to see that we can go right here. And this is going to be a square. And then we're going to add it all up. So we have 2 squares right here. 1, 2. And then add our triangles that we just did with our circles. 1, 2, 3, 4, 5, 6, 7. And then 4 circles. And you can see that both sides equal each other. So then that would be correct. That's just kind of a fun way to do it. It may take more time, but I've seen a lot of students, it's easier just to do this. Now for the standard subtraction algorithm, again, it is broken into steps and it kind of gets a little tricky, so make sure you're paying attention. Step 1, just like addition, you're going to put the numbers on top of each other, ensuring that the place values are lined up. 2, subtract column by column, and I really want you guys to pay attention to this right here. If the top digit is less than the bottom digit, the digit of the top column to the left changing is going to be 1 less plus 10 to the original digit. And we're going to see this in the examples below. And if the digit to the left is a 0, keep crossing out the digits until you reach the first non-zero number, replacing 0 with 9. This process can be seen as regrouping, trading, and borrowing. So for our first problem, we have compute 172 minus 83. So going to our step 1, we're going to be putting the numbers on top of each other. And then we're going to subtract column by column. So starting with 2 minus 3, oh, we can't do that. We're going to be going to the left. We're going to be subtracting, oh my gosh, sorry, excuse me. Subtracting 10, so 7 is going to become a 6, and then 2, we're going to plus 10 to 2, and this is going to equal 12. So then we have 12 minus 3 equals 9. And then we have 6 minus 8. Ooh, we can't do that. So we're going to go back to the left. We're going to take out 10. And 10 plus 6 is going to be 16. 16 minus 8 is 8. And then we just subtracted, so it's 0. 0 minus 0 is 0. So your final number would be 89. If we want to use the bundles theory for this, we can say, okay, 172, this equals 1 square, 7 triangles, and 2 circles, and then 83 equals no squares because there's no hundreds place, but 8 triangles and 3 circles. So we are subtracting 83 minus 172 using our shapes. So if you want to do this on your own, I'll give you a couple seconds to do it on your own. And then you'll be able to determine that the 100 is going to be taken away because you're removing that, and then you would end up with, these would be, you're going to end up with 8 triangles, but in the process you receive 3 circles. We're going to remove these just so it's easier for you guys to tell. So you use this and you'd get 89. For our last one, we're going to be doing a little bit of a bigger number. So it's really important that you're making sure all your place values are lined up. So 223 minus 24. We're going to solve. 3 cannot be subtracted by 4, so you're going to go to your left. You're going to remove 10, making it a 1, and plus 10 over here, making it a 13. 13 minus 4 is 9. Then go back to the left. 1 minus 2 we're unable to do, so you're going to get a 1 plus 10, making this an 11. 11 minus 2 is 9. And then there's no numbers here, so just remember those could be zeros. So 1 minus 0 is 1. And 1 minus 0 is 1 again. And so you would get 1,199. So kind of just writing this out for you. You're also able to do bundles in subtraction as well. I kind of did it for the first problem up here, down here, just for, it's kind of hard for you guys to visualize, so I just did this for it to be easier for you. Bundles can be used as well in the subtraction algorithm, breaking bigger bundles into 10 smaller parts. So that's what I did up here. I broke it down, but if you're more of a visualized person, you're able to see it down here. It gets broken up each time into smaller parts, and then you just add the last remaining part to get your 89. So we don't have time for decimals today, but thank you guys so much, and I hope you guys have a great day.